Okay. Cool. Hi, everyone. Thank you guys for showing up. Last day of the con and all. I'm gonna show you some really stupid shit. Before I start, just one quick question. I'm swearing a lot. Is that okay, or should I use the clean language? Awesome. Let's get started. So I'm gonna show you a research I did with a friend of mine, Yoav. The weird names, I'm gonna talk about that in a sec, but everything you see here we did together, so he's not here, so please let's pretend he's here. I'm going to tell you a story about how to own almost 1 million of those around the internet with a bunch of really stupid vulnerabilities we found and got CVEs for them. So let's start. So the obligatory, who am I? My name is Amit. I work for Cybereason. I do security research there. Before that, I worked for an Israeli government intelligence agency for about 9 years where I did security research. Last year, I publicly outed and shamed the creators of this malware for Mac. And I'm writing some tools for Linux mostly, and they're up on this address on GitHub. And I'm also on Twitter, so if you want to reach out, that's the best way to contact me, so that's my handle on Twitter. And about the name, so this is where I'm originally from, and this is Tel Aviv, Israel. But last year, I moved to here, and this is Boston, Massachusetts. So there's a slight adjustment. So what I'm going to talk to you about, so let's go. I'm going to do a quick device overview of this little piece of crap. And I'm going to basically lay down everything we did, which is like mapping the attack surface and how we did the vulnerability research. I'm going to talk about the exploitation itself, and I'm going to show a bunch of demos that I hope that they're going to work. So let's start with the story. So this is Yoav, and I've been to his place a while ago. It was before I moved. And it was a Saturday, and we were bored, and we said, let's hack something. And he had this router on his desk, and it took us literally 10 minutes. We were like, okay, this is boring. What else we have here? So right behind his monitor, he had a security camera that he just got, and it was like still closed in the box. So we looked at this camera, and it looked like this, sort of. It's like really made out of plastic. It looks like super cheap. There was no any like, you couldn't see any branding on it. And when something looks cheap, feels cheap, it usually means that turning it into that thing is not that hard. So let's do a quick overview. Wait, this is really I have no idea what the banana has to do with anything. So let's look at a quick overview on this camera. So this camera is actually, they're calling it a cloud IP camera. Like all of the box says cloud IP camera. If you want to get one on Amazon, you just look for a cloud IP camera and you'll find it. Now the thing is about those cameras, and I'm gonna mention that soon, is that there's basically one generic manufacturer, like a Chinese unnamed company, and they make the board, they make the software, they make everything, and then they sell it off as white label for other vendors to slap their sticker on it. So if you hack one of those, you've hacked all of them. It's running its own brewed version of Linux. So it's I didn't say it. It's an ARM architecture, so it's an ARM CPU, it's a system on a chip, so it's basically, there's like one board with the CPU and the memory and like the network interface, everything is on this one board. It's running its own brewed version of Linux, and it has BusyBox, and if you don't know what BusyBox is, it's basically a basic toolkit of all the POSIX and Unix tools you need, and it's like in one statically linked binary, and it's a multi-call binary, so basically, if you do an ls and slash sbin or bin on the camera, you'll see something like this, where see the pointer, yeah. So you'll see that all of those commands are basically linked to BusyBox, and then BusyBox says, oh, you called me by running sysctl, so it means that you want sysctl, but it all lives in one binary. The reason for that is that those devices have very little space and very little memory, and everything has to be super efficient. And this is also why oftentimes the code sucks, because people are like, hey, I did something and it compiled, so if it compiled, it's fine. I'm not gonna pay attention to security. It also has a bunch of really, really, really old stuff on it. So this is a brand new device. Like this one I got back in December, and it's running code from like 10 years ago. So everything you have on it, if it's like the kernel, if it's a bunch of user space tools, everything is really, really, really old. And you know, if it's old, it's vulnerable. And as I said before, if something compiles, usually when people are developing for these things, if it compiles, it's okay, and it's never okay, because, you know, security. A little bit about the camera itself. So they have something that's called a PPPP protocol. And I'm not going to go into that because that's a talk of its own, but I'm just going to say what it is because it's important. Every camera has a QR code on the bottom. And that QR code basically identifies the camera. So it's made for people to just take it out of the box, plug it into their network, and use a really shitty mobile device, a mobile app, scan the QR code, and then there's like a protocol that like bypasses NAT and stuff. Oh, it just rebooted. Great. And I shouldn't have lifted that. And that protocol is also vulnerable, but that's a talk of its own. But basically, the reason I'm mentioning this is everything I'm going to show you, I can also do it through that protocol. So all I need to do is enumerate all of the IDs of the camera, and I own every single camera that was ever connected to the internet. As I said, this particular camera is made by a company that's called VStarCam, and they make everything, and then they sell cameras without any branding. So I don't think this one, there's a logo here. This one has a logo, but basically they just make them without any logos and sell them to other vendors, and those vendors slap their logo on it, and so on and so forth. Now, the cool thing about it is that if you go to their website, you'll see this. And then where they say, no more security vulnerability worries. Wow. That's bullshit. As I said, they have horrible Android and iOS apps. You can do a lot of nasty shit with those apps too, but we're not going to talk about that. And the important thing that I want to focus on is that it runs the Go-Ahead web server. Anybody here knows what the Go-Ahead web server is, other than this? Okay. And of course, a web interface is just a clusterfuck of elementary school level code that was mashed together and somehow managed to compile. And as I said before, it's not cool if it just compiles. It's also really popular. So around the time we started that research, we managed to craft like this really cool showdown query, and we found more than 800,000 devices connected. That's 800,000 shells. And I think that we published that research, and now there's a little less of them, but there's like still around 780,000 of them out there. Also, it's being sold on Amazon and eBay, and it's really cheap. Like, those things are like $30. So if someone goes to Amazon or eBay or other website and he looks for a camera, like a security camera for his house, he says, oh, wow, it's like $30 and it has an app and I don't need to fuck around with my router? That's super cool. I'm getting 10 of those. So that's why they're so popular. And yeah, I got all of those, all from different brands. All of those are vulnerable. You can see that most of them look exactly the same. I got them from different stores. Some of them had this was like a PR shoot we released, so that's why I had to hide the brands. But you can see that a lot of them look the same. But I got them from different vendors and places and stores. Sorry? Why there were brand names?
Yeah, why did you hide them?
Oh, because I could only reach out to one. I sent a bunch of emails to many vendors. Nobody responded. And since VStarCam claimed that there's no security vulnerabilities, I felt comfortable to fuck with them and not with the rest. But this was like, my company arranged this, so I'm not arguing with the general counsel. So if this says something, yeah. Good question though. Yeah, so let's talk about Go-Ahead HTTP server for a sec. So as I said, this thing, the HTTP server that runs on it is called Go-Ahead. And Go-Ahead is a product that's made by a company that's called Embed This, which is a pretty clever name. And the whole thing that's special about it is basically it's like a full-blown HTTP server that can do a lot of things, but it's really, really small. So this is from their website. They tell you, you get like, a single executable, statically linked probably. It's 115 kilobytes when compiled, and you can do whatever you want with it because it's a web server. If you look at its features on their website, you'll see all of those features and then something that's called a CGI handler. Now, if you don't know what a CGI handler is, it means that it's a common gateway interface. And what that means is that it's basically just code that's being executed on the server side with input that you're giving to it from the client side. Think about it for a second, because this is a terrible idea. And this was really popular in the 90s, and the 90s are over. This is a bad fucking idea, and you'll soon see why. The CGI functionality, so part of that web server, part of it is open source, and you can add stuff to it. So you can add stuff to the CGI handler. So you want to say, so I'll give an example why it's a bad idea. In this camera for a second, what they did, if you want to set up the IP address. So what happens is you have a web form and you say, okay, I want the IP address to be 1.1.1.1. And when you hit submit, what happens is that it just runs ifconfig on the back, which is like a native Linux command, and it passes the input from the web form directly to it. Do you understand why this is a bad idea? And when you are compiling that functionality, it will be added into the binary. So if you'll reverse engineer it with IDA Pro or something, you'll be able to see it, and I'll show this in a few minutes. So back to our research. So what we wanted to do, we were looking for remote code execution. We wanted to pop a shell on that thing. But we did have one problem, and we couldn't find the firmware. So, because if you want to do such research, what you usually do is you just find the firmware, you start reversing the firmware, looking for vulnerabilities, and that's it. There you go. You have code execution. But in that case, it's like a shitty vendor that has hardly a functioning website. We don't even know what the model of this thing is, even if we can find some sort of an FTP site with all of the code. And we had no way to get the firmware. So that means hammer time. We literally took a hammer. So this is the camera. We took it apart. And this is the board. CPU is around this area. Memory is here. A bunch of switches. That's the network. That's the RJ45 plug. And what most of those boards have is something that's called a UART. Now, a UART is a serial port, which will basically give you an access as if you had a keyboard and a screen plugged in directly to the console of that device. So all we had to do is to find those UART headers. Once we did find them using a trusty bus pirate, we plugged in some wires, we found the terminal speed and everything, we plugged this to the electricity, and we saw the bootloader. So that means we're cooking. So we waited for like 2 minutes for it to finish booting, and then we had a root shell on it. Which is cool, but again, it's hardwired to the device. It's still not remote code execution. So, okay. What do we do now? Because we want to get the files from the camera to a computer with like IDA Pro or something and start looking at it. So basically what we did, since we had a root shell and you have BusyBox and everything, we just used DD and Netcat to just copy things directly from the block device to our computer, and we had the firmware. And then we just used binwalk on the MTD block. And we extracted the files with no problems, and I can zoom in just real quick here. And you basically can see, like, that's the file system, that's the offsets of where everything is, where there's the image header, there's the bootloaders, there's the actual file system. So now we have access to the files. So after we have access to the files, we reevaluate it. So we know that it's a brand new device that runs a kernel from 2008. We know that it's running Go Ahead Web Server. We already figured that out. And we know that the source code for it is available. So that's cool because it makes reverse engineering easier because we can just read the code. We also saw a lot of really, really, really poorly looking code, and that's the stuff I was talking about, like extra functionality that was added through the CGI handler to the web server, and you're going to see that in a moment. It's dumpster fire. And we also found a file called system.ini, which was it had some binary shit, but it had the password, the password for the web access in clear text. And this file was in the web root directory. But this file was protected with a password. So we couldn't ask for the file because then it would ask us for the password. But there are so many crappy things on top of each other here, then something has to be vulnerable. So let's talk about user-controlled input for a second. So as we all know, when we're doing vulnerability research, the easiest thing is to look for where the user interacts with the program. And if we can affect something in that way, something in that process where a user interacts with the software and says, okay, I want you to do this. And if we can make something happen in that process, if we can tell the program that we're talking to do something else with the input that we're providing, then it means that we can change the way things are acting. And this is pretty much what command injection is, or buffer overflow is. Yeah, I just said that. And programmers make mistakes. Always. It doesn't matter if it's a shitty IoT device or if it's the Windows kernel. People make mistakes, and when people make mistakes, this is where hackers come in. So let's start by mapping our attack vector. So where are there user control strings? Where can we manipulate something? Where is the code that handles that user control strings? And is it vulnerable? And if it's vulnerable, how hard it is to exploit it? So the first thing you do when you want to set this thing up, you fire up a browser and you go to the administration panel. So that's like the IP address, that's the port, and you immediately get a password box. So there's some user control strings right there. So we looked at the login process. What happens when this box pops up? And the code actually seemed to be pretty okay. I mean, it's basically just comparing, it's comparing the username and password that you're giving it, and then it just looks at that file, at system.ini, and if, it just compares what you've given it and what's in that file. We couldn't find anything there other than a buffer overflow, but yeah.
Is this the way of code that you're looking at as far as the code that's handling the string?
The question is this the way Go Ahead handles things? So pretty much every web server handles, it's HTTP, it's a common protocol, but every server does a different thing, a different way of handling things. Like in that way, it's comparing it to a file. Other servers have like a database, but it all depends on the particular server. We did find a buffer overflow in this thing, like we could give it like a really long username and it would crash, but buffer overflows and shellcoding and debugging is hard, and we don't want to work hard because it's a Saturday and we were lazy. So at that moment we're like, yeah, now we have to start debugging things and like seeing where the memory aligns, and nah, none of that. So let's think about it for a moment again. What is the first point of contact of a user controlled strings with the web server? And this is the web request itself. So let's talk about HTTP request for a quick second. This is a really, really, really simplified version of an HTTP request, but it basically looks like this. There's a GET, which is what you want from the server. I want you to give me a file. There's the path to which file you're asking, and there is the protocol in which you want to work with. So in this case, we're asking the server to give us the page /index.asp. / means that it's the root folder, and HTTP/11 is the request protocol. The server will then say, okay, if everything looks okay, if the page isn't protected by a password, if the page exists, if the request looks legit, the server will say, okay, here's what you're asking for, and the server will respond with an HTTP 200 okay response. So let's go and find the code that does that. So as I said, it is open source. Parts of it are open source. So we just went really back in the versions because, again, like this was a brand new product that runs code from like 10 years ago. So we had to go really back, way back and found the code. So we started looking at the function and we found this function that's called webs get port, and this just takes the request and just kind of figures it out. Okay, there's the protocol, there's the path, there's the host name. So we're like, okay, we're in the right place. We then found this. Now this is pretty interesting because this is what happens if the server processes a request that's kind of not okay. So HTTP has a response call that's called 400. It's right here, 400 bad request. And that means that if you send an HTTP request to the server that doesn't conform with the HTTP protocol, the server is just going to say, what the fuck do you want from me? I have no idea what you want. And it'll give you a 400 error, which basically means I don't understand what you're asking for. So if we look at this simple if statement, we can see that the only time that the server will return a bad request will be if the request is not a GET, if the request is not a POST, and the request is not a HEAD. So these are all types of HTTP requests. If you'll send a GET request, doesn't matter what it looks like. If you'll send a POST request or a HEAD request, again, doesn't matter what it looks like. It has to be one of those. The server is just gonna take it. If it's not a GET, a POST, or a HEAD, the server is gonna say 400. I have no idea what you want from me. So let's do a quick recap because it's starting to get a little bit complicated. So an HTTP request is considered legit only if there is a slash in the beginning of it. So if you remember, I'll go back. There is a slash here. It means, okay, because we always start from the root, and the root is slash. So if there won't be any slash here, the request is broken. So the first thing is there a slash in there? And in the code, it's URL, it's an integer, it's called URL, and it's position 7, because that's where the slash is. http://. Also, as I said, there is no real exception handling. And this is really bad, because if you make the server think that what you're asking is legit, but it's not, then you can do whatever you want. And this is where we came in. So I'm going to show you something here. So if we send a GET request that looks like this, and this is the file with the password, and let's do that real quick. Can you see that? Go away. Okay, camera rebooted, so let's hope it's still, okay, cool, it still has the same IP address. So let's telnet to, this is the web port, right? And we're going to do get/system.ini http, and it's going to say unauthorized. HTTP 401 unauthorized. I can't ask for that file because I'm not authorized, because this file is protected with a password, and this file has the password. So if I'll open my browser and I'll go to the IP of the camera /system.ini, I'm going to get a password request. Something is kind of, oh, I'm zoomed in still. Okay. But what will happen if I'll do this? And again, there is no slash here. So what will happen if I'll do the same thing, but I'll ask for system.ini without the slash in the beginning? I'm just going to get the file. Nice. So this is the username, and this is the password. Now, I wanted to do a really nice demo, and I really wanted to impress you guys with like a really complicated password. But no matter how complicated the password I got in, the server wouldn't get it. So I said, what the fuck is going on? So I started reverse engineering the code that handles that, because that wasn't open source. And apparently, apparently someone used an or instead of an and, so the password can only be all lowercase, all uppercase, or all numbers. Wow. So this is a complicated password. So as I just showed you, we have the file, we have the username, and we have a password. Live demo number 1 worked. Yay! Okay. But then you say, oh, so you just got the admin panel. This is not interesting. Okay, so you can look at the images of the camera. You can move the camera around. Big fucking deal. This does that all the time. But then I started doing my favorite thing, which is just walking around the administration panel. By the way, you can see how beautiful this administration panel is. And I found this page, and this page basically allows you to set an email alert, and every time the camera detects a motion, it will send you an email. Hey, I detected a motion, someone is in your house. And it takes very simple input. It takes your SMTP server, the SMTP port, the username, the password, and you have the option of setting like 4 different recipients. So I did what I always do when I come across those forms, and I just type semicolon reboot and everything. And if I submit it and this thing reboots, it means that I have code execution as root. Now, one thing that's also important, I totally forgot to mention that. Usually on those devices, there's only one user. That user is root. So everything runs as root. The web server runs as root. So if this thing reboots, it's code execution as root because only root can reboot the machine. So I wrote reboot, I hit submit, and that thing just rebooted. So, yep. So that means that there's code execution as root. And that means that someone is calling system with user input. Now, system is a standard function in C you can use, and basically it looks like this. And you just call it, and then you tell it what you want to run, and it'll run like a shell command. And I can never stress that enough. Passing a user-controlled string to system is a bad fucking idea. And this thing happens all the time in 99% of those devices that I'm looking at. And it's funny because on that router it happens too. And literally every router, IoT, embedded, however you want to call it, every device I'm testing, there is always one page that does this mistake. So what can we do to avoid it? Always sanitize input. Always sanitize input. They didn't do that. Look for a semicolon, a pipe, end-to-end, or a backtick. Like all of those, you can use them to inject code. Also, sanitize those and their HTTP encoded versions. Now, never pass a user control string to system. There is no reason to do that. This is just stupid. And this is what they did. So I wanted to look at it in IDA Pro and see, because this part was compiled. This wasn't open source because this is something that the camera vendor added. So I wanted to look at this in IDA and see if I'm seeing what I think I'm seeing. And yes, they take your user control string and they just echo it and pipe it to mailx, which is a simple program that sends email. And this is like all the user control strings that you put over there. And they're literally just printfing that and calling system. So that's like really, really, really bad. But then again, we have code execution as root, so fuck that. So this is basically my demo, and what I'm going to show you here is that instead of writing semicolon reboot, I'll just use that. Now this is my favorite trick. I'm always using it. It almost always works because if you remember at the beginning, I talked at BusyBox, and when you're compiling BusyBox, you can choose what kind of components you want to add into BusyBox. And again, it makes the binary larger or smaller, but almost every vendor compiles Telnet D into BusyBox. And Telnet D is a Telnet server. So I don't have to write shellcode. I don't have to do complicated stuff. I don't have to redirect pipes, like input and output pipes. I can just fucking run Telnet D and I get a shell. And that's like my favorite trick that I'm gonna pass it on to you now. So what I always do is I do semicolon Telnet D -P 4444. That's the listening port. And then the -L is the cool trick. By the way, there's no space in there. Like this is on purpose. And the -L is a really cool trick because what happens when you the default option is if you don't include the -L. So the default option is that what's going to run is a process that's called login, and login is exists on almost every POSIX operating system. So login will just ask for your user and password. But we don't know, I'm fucking out with this terminal. We don't know what the user and password is in that case. Because we just don't know it. We didn't close the image. We don't know what the root password is. But if we'll use -L, basically, that flag means, what do you want me to run once a connection has been established? And I'm like, because the default is login. I'm like, no, don't run login, run fucking DNSH. And he's like, okay, root shells for everyone. So, yeah, let's do the demo. So, what I did is I actually sat down and I wrote like an exploit. Of course, I got the spinning lollipop of death, fucking Max. So this is the exploit code I wrote. It's 61 lines of Python, including nice printouts and stuff. Like, it's really simple. The only thing that was like really hackery here was just send the broken packet, which is this, the getsystem.ini. And the reason I had to do that manually, like this is a raw socket that I'm like opening, I'm writing that request and then I'm reading the buffer from the socket. And the reason I had to do that is because this is a broken HTTP packet. No HTTP library can provide me with this functionality because this doesn't conform with the HTTP standard. You can't ask a Python library to ask for system.ini because you always have to put a slash in there. So that's the only thing I did. I mean, I crafted that packet, I got the binary, then I'm just, I got the system.ini binary file, then I'm just parsing it with a bunch of regexes, and then spawning the root shell thing here. So it's good to see that only PyCharm shit the bed. The rest is still working. Okay, so I'm gonna show you the demo real quick. So let's go to PyCharm projects. I called it Campone. And I'm gonna run Campone, and I'm gonna give it the IP of the camera. It was, do you remember what it was? 1.2. 1.2 and the port. So what's gonna happen now is it's gonna send the broken packet, get the password, run the shell. So I'm running it, send the packet. God damn it, I think the camera rebooted again. Of course. Let me see if it's still working. I think it's still working. Yeah, need to reboot it. Okay. I'll give it a second to reboot, and I'll get back to demo in a second. What I wanted to tell you is some interesting facts about this vulnerability. That slash vulnerability thing that I showed you, apparently another researcher found that back in 2004 on a printer. Like a printer, I forget which, was using the same go-ahead server, the same version, and he found that same vulnerability back in 2004. So what we thought was a 0-day was in fact 4,745 day. And again, that's what blows my mind with those devices. We got 2 CVEs for those discoveries. One is that the slash vulnerability on this wide range of devices. The second one is that command injection I just showed you. Another researcher called Pierre Kim discovered almost the same vulnerabilities, and for some reason he also received CVEs for that. And us and him are the one to blame for the new botnet that's called Persirai, which is like Mirai, but with those pieces of shit. So there's already a botnet that we're guilty for, so I'm sorry about that. Let's see if this thing booted already before I wrap this up. Do I still have time? Do I still have time? Oh, I have plenty of time. Okay. So let's see if it's working again. Okay, awesome. So let's run the exploit now. I'm gonna clear the screen. I'm gonna zoom in. Okay, demo gods. Yay! Okay. So as you can see, it sent the password, it sent the broken packet, got the info leak. This is the password, remember? From before, this is the password. Now it's authenticating with that password and calling that form and sending it that telnet thing. Now the way this works is that it's actually trying to send an email to telnet blah, 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 blah. So we have to wait about 20 seconds for this process to say, I have no fucking idea what semicolon telnet is. And it's done. And now we're going to connect on port 4444. And I wrote in the wrong IP. And yay, we have a root shell. Now, thank you. Yay. Thank you. Okay. Now I know what you're gonna say. You're gonna say that's bullshit. That's a bind shell. That's not accessible from the internet. You have to redirect a port for that. This is bullshit. So actually not. I mean, I actually had the same thing for a reverse shell, but I lost the file. It's really same principle, but I lost the file. But the cool thing about this camera, because it has to like redirect ports and stuff, it has a UPnP client on it. And in case you don't know what UPnP is, it's basically a terrible protocol that just talks to your router. It sends it like XML SOAP packets and basically say, hey, I need you to open this port and redirect it to me for like 20 minutes, and then you can close it. And what's going on is that your router gets this packet, if UPnP is enabled. And your router sees, okay, so this IP address sent me this request. It's in the internal network. I'm going to honor that request. I'm going to open that port for like 20 minutes or whatever's written in the request, and I'm going to forward that port, because that's how a lot of things works. Because you don't want to go to your router and open a port every time you use Skype or something. Now, the bad thing about UPnP is that it depends on the router. In a lot of cases, you can't see that it actually opened any ports if you go to the control panel. So this is a screenshot from IDA Pro. You can actually see that there's a client called UPnP static -D. This is the port number you want to give it. So this is a number, and TCP is the port. So you want to say, okay, so UPnP -static -D 4444 TCP, and that's just going to happen. So this is UPnP static on the router running. So I brought the wrong router. This router can't do UPnP because I fucked it up. I wanted to show you that too, but you're going to have to believe me on that one. So basically, what we can do in order to exploit that from the outside world is run the same exploit, open telnet D, and also do like semicolon UPnP static -D 4444 TCP, enter, wait for that to run. The camera will say, okay, I have a telnet server listening on port 4444. It's going to send the router a request saying, hey router, I need port 4444 TCP forwarded to me. The router is going to say, okay, there you go. The router is going to open that port, and then you can connect from the outside to the camera with actually manipulating the port forwarding tables on the router, and nobody knows that.
How do you run your exploit? How do you get to the web server in the first place?
Because that's what the user uses to access his actual video feed from the camera. So that port is already forwarded. Port 81.
Initial integration.
Yeah. Thank you. Oh, one very important thing I forgot to mention. The title of this talk is called "The Tale of Blah 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 with No Patch Ever." The reason I wrote that is that you can't patch that. There is no firmware upgrade mechanism built into that thing. So even if the vendors will respond to the emails I've been sending them for the past 4 years, they'll say, I'm sorry, we can't fix that. So those things are vulnerable till the end of eternity. So if you do have one of those cameras, and if you'll just Google my name, I forgot to put it in the slide. If you'll go to cybereason.com/IP-cameras, there's like a list, and there's a tool that can help you to identify if you have this camera, if this camera is vulnerable. We wrote this tool in a way that you don't need to provide any information. You don't need to put in any IP addresses. You basically look at the QR code that's on the back, and you write a bunch of things that are written here on the sticker, and it's nothing that identifies you. Like we don't save this. We have no idea what to do with this, but this will tell you if your camera is vulnerable. And if it is vulnerable, just do this. Questions? Okay, going once, going twice. Thank you guys.